I don't have a single problem going to sleep. When I'm sleepy, I go to sleep right away. Today was not one of those days. I ended up tossing and turning for quite a long time, actually. But seems like my cat can't sleep either. Maybe it's the air purifier that I turned on. It's literally making me sneeze so much. But yeah. So we're gonna move on to the third lecture and then do the side book. And then these Python files and the coding, I think I'll go over them afterwards just because like Zybook already has all the coding functions and all. So this is based on relational database, right? So the introduction, the data you need will often live in databases, systems designed for efficiently storing and querying data. The bulk of these are relational databases, such as PostgreSQL, MySQL, and SQL Server, which store data in tables and are typically queried using structured query language, a declarative language for manipulating data. Relational database. So a relational database organizes data in rows and columns of tables. Tables are related with special columns called keys and queried with structured query language. So let's write that down. Oh, this pen doesn't work. When does one of my pens work? Let's see, this one. Relational database. Data stored in tables with the special columns called keys. And queried in SQL. Structured query language. Here's some examples. We have the country and the city. Y'all can't see my cat though. I think that looks good. Okay, so we have the relational database. Next, we have tables. Table has a name, fixed sequence of columns, and varying set of rows. Column has the name and data type. Row is an unnamed sequence of values, each value corresponding to a column and belonging to the column's data type. So in these tables, they know row names. So table has at least one column and any number of rows. Tables obey the following rules. One value per cell, no duplicate rows, no row order, and no duplicate column names either. So just one value per cell, no duplicates, no order for the rows. And the last rule is called data independence, which allows tuning physical data organization to improve performance without changing any queries. So here's some keys. And a unique column it's a lot of adjusting. This is because I can't see the cat though. No, I can't see what I'm writing. Priorities. Oh, this is fine. It's fine. Oops. Alright. So, keys have a unique column that never contains duplicate values in different rows, as we mentioned already. So every table has a primary key. Primary key is a column or a group of columns that identifies individual rows. So these are individual rows. So foreign key is a column or group of columns that refer to a primary key. So foreign key values must be either a null or a match. So value that references the primary key. So this is the foreign key. This is the primary key. Yeah, it's basically like a table in a table. And then, unlike primary keys, foreign keys are not necessarily unique. Wow, so primary keys are unique. And then, what is that? The foreign key is not unique. Got it. And then we have next the SQL, which we already went over the first slide, but it is the structured query language. It's a computer language for manipulating and retrieving data. It consists of language elements like keyword, which is a reserved word with special meaning. A literal is a fixed numeric or text value. Text literals are enclosed in single or double quotes. An identifier is a user-defined name for a table, column, database, and so on. So a clause groups a keyword with identifiers and expressions. A statement is a complete database action consisting of one or more clauses and ending with semicolon. Hello Sabian, Alfaro, Petra, Ruada. Welcome to the stream. Nice to see you. Let's see. Here's some SQL language elements. There's a keyword, a literal, identifier, clause and statement. And then, yeah, next we have they're used to perform tasks such as updating data on a database or retrieving data from a database. So common relational database management systems that use SQL are Oracle, Sybase, Microsoft SQL Server, Access, and MySQL, etc. So these are just different softwares that utilize SQL, but this is SQLite, which is a C library that provides a lightweight disk-based database that doesn't require a separate server process and allows accessing the data. Hello, welcome to the stream, Emmanuel Saddam. And allows accessing the database using a non-standard variant of the SQL query language. Let's read that one more time, just because I'm not really sure what the difference between SQL and SQLite is. So, focusing on the difference, it doesn't require a separate server, but does allow accessing the database using a non-standard variant of the SQL query language. So it's a non-standard variant that doesn't, require a separate server process. So that's what makes it light. So to use the module, start by creating a connection object that represents the database. So this is the connection object, right? No, not that. This one. Okay. So special operators in the in operator. This is used in a where clause to determine if a value matches one of several values. So let's say here we have from country language, where language in Dutch Congo Albania. And now you see the percentages, the officialness, I guess. So yeah, if it matches, that's what the in operator is used for. It only happens when you use the where clause first. So some other examples, like. So like is also another thing, just like our last one. What was that? The in operator. So in and like used the same way, where the where clause is come first. And then from country language, where country code like A_W. And yeah, I mean, I'm not really sure where the output matches in terms of values, because these all look pretty different to me. But I guess these are all the values for, I guess it's like searching a keyword like CTRLF, So I guess that makes sense. So like and in operators only work with the where clause and help you search the information based on whatever you are trying to look for. So aggregated functions. These are processes. This processes values from a set of rows and returns a summary value. I've had to do this quite a few times in regression analysis, but it appears in a select clause and process all rows that satisfy the where clause condition. So if a select statement has no where clause, the aggregate function processes all rows. Did it not say that it processes all rows already? Oh, so it only works on the where clause first, but without it processes all rows. That makes sense. And then here's some common aggregate functions. We have the count function, min, max, sum, average, and variance. So these are all pretty standard, but they're called aggregate functions. So to group by clause, the group by clause groups rows with identical values in a set of summary rows. So some important points about the group by clause is that one or more columns are listed after group by, separated by commas. Let's repeat that one more time so it makes sense. one or more columns are listed after group by, separated by commas. Alright, and then the group by clause returns one row for each group. Each group may be ordered with the order by clause. Group by clause must appear before the order by clause and after the where clause if present. So if we are to take a few notes about the group by clause, what could we say? Rows with identical values in a set of summary rows. And then one or more columns are listed after the group by, separated by commas. And then each group must be ordered with the group by clause. And the clause must appear before the order by clause and after the where clause, if present. So first comes group by, then the order by, but if there is a spot before group by, then that's where the where present would be, the where clause, right? So we have three clauses, and yeah. So next we have some examples of the group by clause. So it's not like sacrificing either one. Still show the examples. We have the names of certain cities. I've never heard of any of these names. But oh, okay, so that makes sense. It's all in Zimbabwe, I think. I don't know what this is, I don't know what that is, but here are the different districts, the different populations, and group by, select from, group by, and there's your output. This is the aggregate measure or aggregate function. So there's another clause called the having clause. So this is used with the group by clause to filter group results. The optional having clause follows the group by clause and precedes the optional order by clause. So if it precedes, it's before the order by. So that'd be in between here. Optional having clause. And then this indicates or includes the same aggregate functions that appear in the select clause. So I would say select comes before group by. Just because of this last example, we have select here and then from here and then group here. But yeah, same aggregate functions. Here's some more examples. But having comes before group, after group, before the order by. So let's say select first, and then from, and then where or group by. Can you guys hear me? Let's see if y'all can hear me, just because I've had issues with that before. Testing, testing. Hello. Okay, so y'all can hear me. Y'all just quiet, huh? That's fine. So the join is a select statement that combines data from two tables. Pretty straightforward. But yeah, in relational databases, reports are generated from data in multiple tables. Multi-tables reports are written with join statements. Multi-table reports join statement. In select. Left table and right table into a single result. Left, right. Okay, and the tables are combined by comparing columns from the left and right tables. Usually with the equal operator. The columns must have comparable data types. Usually a join compares a foreign key of one table to the primary key of the another. However, a join can compare columns and with comparable data types. So here's some examples of the join function, the join statement. So it's in select, but I don't see any join in the code. So, but this is the foreign key. This is the primary key here, and we have select department name, employee name from department employee where manager equals ID. So inner and full join. The inner join is here. We have the red here indicating the join, and the full join has, let's see, all the results. This is the join table together. This is the left join table. This is the right table, and where all of it is red is the full join. I think the inner join would just be two separate columns. Not columns, but two separate keys. This is the primary and the other key. So the left and right join. In some cases, the database user wants to see unmatched rows from either the left or right table, but not both. To enable these cases, relational databases support left and right joins. So the left join selects all left table rows, but only matching right table rows. And the right join selects all right table rows, but only matching left table rows. An outer join is any join that selects unmatched rows. Left, right, and full joins are all outer joins. MySQL doesn't full join. So here's some more examples. We have the left join key for employee. I guess we're trying to match right join in play looks like this. Okay. What are the differences? Let's see, we have engineering, sales, marketing. Those are pretty standard. Similar. Technical support is different because this is null here. And the left join brought that over here, did it not? Because now you have all the names of these people and the code or the name of their roles here. But when you do the right join, you're bringing these names over here, and you have Lisa Maria Rodriguez, and Sam Snead here is null because, well, he doesn't really match the ID, does he? No, he doesn't have a group, which is weird. I guess he doesn't have a group. But yeah, let's see the last slide now. So the data will often store in databases, systems designed for efficient storing and querying data. Cat break, stretching. And then a relational database is a collection of data items with predefined relationships between them. These items are organized as a set of tables with columns and rows. So the SQL structured query language is a standard language for a relational database. Yes, with management systems and used to communicate with a database. He's still stretching though. SQLite is a C library that provides a lightweight disk-based database that doesn't require a separate server process and allows accessing the database using a non-standard variant of the SQL query language. And the SQL main queries insert, update, select, and delete. I didn't know that part, but now I do. Select, or not select, but yeah, that is part of it. First is insert, update, select, and delete. Done. Just like that, we finished another slide. But now we can start with our example. This is a lot of pages. This is equally as many pages. This is 37. It's crazy. But yeah, data wrangling. So let's do these participation activities. So map the data wrangling step to the activity. Like, I'm gonna need y'all's advice on this. What do y'all think? So, deriving a new feature per capita income by dividing total income by population. I think population would be the standard deviation, would it not? I'm not sure about that though. But this sounds to me like the z-score, which is, well, definitely not cleaning. Let's see. Changing the units of all distance features to meters. Well, I think that's structuring. Right? Or is that cleaning? No, structuring. Yeah. Hello, welcome Brody Hill. Updating a dataset CSV file to iCloud for analysis by other data scientists. That's the last part is publishing. Create a scatter plot to inspect raw data. Love the vids. Thank you. I haven't seen you on the live streams before, so it's nice to see you on an actual one. You are smart. Thank you. You are smart too for choosing to watch some educational streams. But yeah, placing missing values in a feature with the mean of known values. This is validating. But before we put that, let's look at the other ones. Deriving a new feature per capital income. I would say that's discovery. And then creating a scatter plot to inspect the raw data. Verifying, well, this is validating, right? For sure. Verifying all two-letter states abbreviation or valid states. Definitely validating. Now, press Control W. It helps sometimes. Helps with what exactly? So replacing missing values in a feature with the mean of known values. So this is discovery. No, it's not. That's crazy. What would that be? Cleaning would be replacing missing values. What? Discovery would be creating. Oh, okay, that makes sense. Because this is the raw data. You haven't yet seen it yet. Alright, so deriving a new feature per capita income by dividing total income and population. Definitely the z-score that I was talking about. That's enriching. I do it on my computer. Oh, mine is not lagging actually. It's probably just the stream. So yeah, that's that. I did mix up enriching with discovery, but now that I've seen the raw data part, I know that's not to be mistaken in the actual exam. So, data wrangling versus ETL. ETL is, let me try to remember. It's the bougie way of database. Yeah, honestly, I can't remember. But it doesn't matter. Which process structures, cleans, and enriches data? Well, wrangling is what cleans the data, right? ETL, it doesn't focus on cleaning because it's a lot of data. They usually focus on high volumes of data. Trust me, press Control W. Now I'm getting suspicious because I don't even need to. My laptop's not lagging or anything. But let's verify what this means. Control W. Closes current tab. Wow. Very smart. Very smart of you. Which process structures, cleans, and enriches data? It's data wrangling. Yeah, I'd say it's data wrangling only. No! The T in ETL stands for transform. Transforming data includes structuring, cleaning, and enriching. Yeah, but they don't really. It's more automatic for ETL. I guess it's both then. Okay. Which process periodically extracts data from transactional database systems? Periodically extracts data from transactional databases. It's probably ETL only. Yeah. Because look, it even says here it's an automated process that automatically transforms. So it's not really wrong to say only database cleans, but I guess that is wrong because it's not asking whether it does it like manually or automatically. Which ETL tool vendors do do not offer database system products. He wants to study too. I would say Informatica and Talent. Yeah. Next. Which pandas method imports a data frame from CSV file? I just knew it's this because I had to do that myself. And then which pandas method returns information about the data frame? Say this one. Okay. I was actually a little hesitant there because I had to do lock. That was pretty important as well. But the first one I didn't see before. So 4.2, structuring data. Alright, let's do this. Refer to the following dataset, match the column to the formatting inconsistency. So, no consistent issues. Let's see. Manufacturer. Yeah, there's no issues here. What? Inconsistent text format. Inconsistent units. This is a bit hard. Inconsistent categorical values. I think drive is for this one. Yeah, it's inconsistent. It's like, what is that? You have 2 rears, 4 wheel. Nah. Inconsistent units. Well, what's a unit? It's the liters, huh? It's inconsistent because you have one outlier. And inconsistent text format here. Well, nothing seems to be wrong for the text format. But I guess the only option is manufacturer. And no consistency issue would be the model. But how's the text format? Oh, because Ford is capitalized and BMW is capitalized. But, you know, you'd think it's supposed to be like that, but nah, there you go. Alright, next we have the house of the price of this is above the standard deviation. Refer to the data sets in the animation above. Okay. 269,500. The age. This is standardized. I would say this is true. Yeah. The house of the price of this is negative. It's not above, it's negative, it's false. Okay. 0.86. I think that's false because it's in the normal. Scales for price and age are identical. Standardized scales for price and age are identical. look like it. What's the scales? It doesn't look like it. The normalized scale for Python 8 are identical. That doesn't look like it either. What is it even asking though? The maximum and minimum values of normalized features are always 1 and 0. So the maximum... Okay. I'll remember that because that's true. It's not above 1. It's not below 0. So it's normalized all the same. Got it. 4.2.5. Wow, that's a lot. Alright, well, let's make a list. Whenever I feel a little bit overwhelmed, I always make a list. A lot of scratch paper, so let me find one of those, or just a notepad. So we have for chapter 4, we have section 2, 3, 4, 7. And then for chapter 5, we have 1, 2, 3, 4, 5, 6. Just because all the other ones are labs. And then for chapter 6, oops, we have 1, 2, 3, 4, 5, 6, 7. 6, 7. Got it. So yeah, it helps to know where you are while you're studying, just so that you know how completed you are. Anyways, let's continue. So, assuming car weight has a minimum of 500 pounds and a maximum of 3,000 pounds, what is the normalized value of a car weighing 2,000 pounds? So that's 2,000 minus the minimum is 1,500 divided by 3,000 minus 500. So I think we did this already. It's, let's see, 0.60, having 1,500 over 2,500. Yeah, 0.60. Yeah. Assuming engine size of a minimum of 1.2 liters and a maximum of 6.4 liters, what's the normalized value of 3.5 liters? 0.44. Yes. Alright. So this is unpacking the data. All information coded in the vehicle identity number, ID number, is unpacked. How many new features are added to the dataset? 7. Because, oh, what? More than 7. Like 1, 2, 3, 4, 5, 6, 7. Oh, okay, so there's no new features. Oh man, what? What new features? I don't understand, but the animation divides the VIN into 7 parts. However, the vehicle description part contains several types of data which become several additional features. How do we know that? Character 4. 1, 2, 3, 4. Through 8 encode information about the vehicle, such as body, engine, transmission type. Well, that didn't really show in the animation. I'm not gonna lie. More than 7? Okay. When the VIN is unpacked, the original VIN feature retains in the dataset. Yes, of course. How should the model year be represented when unpacked as a new feature? The original code. No. Model year. Okay. A year number derived from the code. That makes sense. I was thinking the original code because that's like the the overload feature, and then you reduce that to simple features. But if I had looked at the other answers before answering hastily, I would have thought to put a year number, but also probably not. But that makes sense because it's asking for the model year, how that should be represented. Alright, next we have this: complete the code to standardize miles per gallon. What function would that use? Miles per gallon. Well, it's not these methods. Okay, whatever. I'll just check the answers. Scale. So scaling is the code to standardize miles per gallon. Okay. So right, scale here. And then over here, to pre-processing takes the Minimax scaler to fit transform. I wrote that down, but it's like kind of hard to remember. It normalizes the data input X, cleans data, but yeah. So, what are these challenge activities? I think we're done with chapter 4. No, we still have more chapter to go. More sections in the chapters. Along with more. 3 more sections of chapter 4 and I'm done. And then when I wake up, hopefully if I do, then I will go over the other 2 chapters, chapter 5 and 6. And yeah, hopefully that will be good enough, even though I don't really feel comfortable leaving out these code, because we will definitely be asked on these things. It's not too much anyways. It's not like the first Crash Course that had like 37 pages. I think I'll leave that for last. But these ones we'll definitely have to go over. So, cleaning data. Refer to the following data set. Match the terms. Rolls-Royce Ghost. I have no idea what that looks like. So it's not a duplicate, right? Tesla Model 3. I think that's missing values, right? What? It literally says these missing values here though. Okay. It's not unknown, it's missing. Okay. But then this is unknown. That's Ford. And then the Chevrolet Malibu. Let's see here. We have 6/30/26. What? That does not look like an outlier. But if there's a duplicate, then it's with BMW, isn't it? Chevrolet and BMW. But it's not like the same exactly. Oh, there's a duplicate down here. Okay, yeah, that makes sense. And then the outlier is Rolls Royce. Yes, the cylinder is much larger than others. And the liters. Okay, makes sense. Down here, the Bentley Continental Instance is a good candidate for discarding. Let's look at the Bentley Continental. This is null, nah, not a number, not a number, not a number, not a number. Why would that be a good candidate for discarding if the Tesla has the same amount of values, if not same, but like almost the same amount. But yeah, I guess you could clean more than one. True. So the base price feature is a good candidate for discarding. Let's see the base price feature. Base price. Yes, for sure. It's so empty. Tesla Model 3 instance is a good candidate for discarding. Yep. But there's so many missing values here. It's literally 3. Why would that not be? Okay, although Tesla Model 3 has missing cylinder, liter, and miles per gallon data, this data is inapplicable rather than unknown. It's not unknown. Rather, well then why did we trash the Bentley? Missing or outlier data for many features may be discarded. Okay, so Bentley is too many. Oh, because the engine type is null as well. Okay, so this is empty. This is unknown. This is just inapplicable. Okay, got it. This data is inapplicable rather than unknown. Rather than discard the Tesla Model 3, electric vehicle might be retained for analyses that do not require these features. So it's false. Okay. And then the Tesla Model 3 and Nissan Leaf instances are a good candidate for pairwise discarding. So in pairwise discarding, you keep the empty value sets. But let's look at the Nissan Leaf. So you have a lot of empty spaces here. I would say yeah, just because you don't get rid of it. But yeah, electric cars do not have cylinders or liters instead of miles per gallon. Electric cars efficiency is measured as miles per kilowatt, miles per gallon engine. So electric cars might be discarded for analyses of cylinders, light, liters, and MPG, but retained for analyses of MPGE. Imputing data. So Using mean imputation. What is the new MPG value for Ford? NAN. Well, we'd have to calculate the mean now. Oh, well, that's a little bit tedious. Not gonna lie. But the mean imputation for the MPG value of Ford, that would not include this. So we have 5, 38, 62, 74, 284 divided by 5 is 5. 56. No, what is the mean value excluding the missing value and including the outlier? The outliers are excluded when computing the mean. Okay, so outliers are excluded when computing the mean. Got to remember that. Got it. Next. So, we have 44, 62, 74 divided by 4 is 18.5. 18.5, correct. Assume that a regression model determines MPG equals 40 minus 2 times cylinder minus liter. So using regression and imputation, what is the new MPG value for Ford Mustang? Well, we have 6 times 2, just 12, minus 2.7, 8.3. 40 minus 8.3, 31.7. But that's none of the answers. 40 minus 2 times cylinder minus liter. That's 12. 40 minus 12 is what? 28 minus liters. 28 minus 2.5 is 24.3. The MPG for the Bentley Continental is an outlier. Can a new value be imputed using the regression model? So let's look at this. Bentley can't be. It can't. We don't have cylinders and liters. No. Only if it's imputed. How could you impute these values? Can't do average of that. Let's see here. Okay. So if they are imputed, then MPG can be computed from the imputed values. However, imputing values using other imputed values introduces additional uncertainty. That is not good practice. That's what I was thinking. That was my way of thinking. I was like, if we taking an average of some averages, that's like more errors. Alright, last one for this section. And then we'll move on to the next. Complete the code with replace missing value in the cars dataset of 20. Fill NA value equals true. Drop to remove MPG. Remove duplicates, drop duplicates. Got it. Enriching data. So almost done with chapter 4. I have 2 sections left for this. I'm getting a little bit tired. If not very tired. So, enriching data is to appending data. So which instance has a missing value in the cylinders feature? Well, doesn't look like there's any missing values here. But this is the original data set. If you're appending, then you're getting I said there's no instances because they all look like they got it from another thing. What is Ford Mustang? Yeah, I think Ford Mustang because it's not in the new manufacturer thing. They replaced the Ford with the Rolls Royce. And then the Audi, yeah, it's the Ford. I was about to put no instances. Next, which instance has missing values in the drive feature? Let's see. So all rear, front, rear. But if it looks the same, I don't think it's any. Yeah. So which feature has a missing value in the Rolls-Royce Ghost instance? Engine leaders. Well, we can't say that for sure because we didn't see the Rolls-Royce from before. But I would say engine leaders just to, yeah, because this appears in the original dataset only. So when you append the Rolls-Royce to this one, it would appear, you know, appended. Alright, so next we have the data wrangling step to the corresponding activities, formatting, scaling, and unpacking, deriving and appending, discarding and imputing. That's definitely cleaning. Scaling, I think that's getting the z-score, right? Deriving and appending. Enriching is just the z-score. No. Enriching data adds new features by deriving new features from existing features and appending data from external datasets. I don't know why I thought it was just the z-score. But structuring data is formatting, scaling, and unpacking. That should make sense. That should be my first instinct because format and structure is the same or similar words. So here's some ways to enrich data. I guess I forgot. Okay. Alright. Let's keep going. We have this model or 2 data frames here. How many instances will be in the resulting data frame? If we were to concatenate these two. If we use this cars 1 merge cars 2 how inner. Oh, it'd stay 4 because inner means you're not. Outer is more like you're putting them together. That'd be 4. An inner join or merge includes instances that appear in both data frames. Yeah. Or are they talking about instances like the column names? So that'd be 5 then, because you have cylinder, like 3 repeating, so that'd be 5. What? You're kidding me. An inner join or merge includes instances that appear in both data frames. Oh, I just read that though, like. So you're taking in all the cars, right? No, just these are the 2 different names. That'd be 3 then, but I don't know why it would be 3. 3 cars are included in the inner join: Audi, A4, BMW. So you're only taking what's similar. Yeah. So inner join only takes what's similar. Got it. Next, how many instances will be in the resulting data frame when you do this on the outer? Well, like I said, it's not like they're separate, they're more concatenated. I do want to say 5, just because the Ford and the Rolls Royce. Oh yeah, so we have 5 cars. Which feature will have a missing value in the resulting data frame? I wouldn't say drive, but I will say probably cylinders, because you couldn't. Actually, no. Probably engine lighters, right? Because Rolls Royce doesn't have one. It's not like it's not a number, so it doesn't have one. No. Then cylinders. Alright, so left join added. Since Ford Mustang does not have value of cylinders. Okay, in cars 2, missing values period. Oh, so we know for sure Ford doesn't have cylinders. So Ford Mustang doesn't have cylinders. Got it. Alright. So I think we're done with this chapter. Or a section of the chapter. Well, actually, we're done with the whole chapter itself, right? No, that's just section 4. Still have 5.7. But I don't know if we did this in class. I've never seen this diamond shape before. Doesn't hurt to do it though, right? I don't know. Which diamond is largest? Say 9490, but that's not on the list. 27. Oh yeah, this one for sure. Which has the least brilliance? This one. Which diamond has the clearest color? Probably 0.3 and 0.77. I'm not sure of the color though. Color clear to 10. B to F. G to J. E. Oh, definitely B. 9 and 7. Which diamond is most expensive? 9490. This is pretty simple. Which diamond color rating has the highest average price? Definitely not J. It's either E or F, but that'll be 488 divided by 2 is 44. VG. So D then. How could you even tell the prices then? Oh, EDG. BGJ. G and J. Click on G here. But J prices are so low. Can be E then, huh? What G now? What highest average price? I don't know. Oh, I didn't watch this whole thing, that's why. So, the diamond status says does not contain a feature described the shape of the diamond, but a ratio of the length divided by width gives some insights. Which ratio would a cushion shape diamond have? Square round. I'd say it's nearly 1 because it's a square, right? It's not like a curve or anything with rounded edges. Less than 1. So divided by width. Width is fine. What ratio would a pear-shaped diamond have? Elongated with a point at the top and round at the bottom. This is near 1, right? No. So primary shape is a raindrop and length is greater than the width. Oh. So square is same length and width, but this is pear shape looks like a raindrop. Since primary shape is a raindrop, the length is greater than the width. Width is horizontal. Divide is length divided by width. So that gives some insight. The length is higher than the width. Greater than 1 then, huh? Yeah. Ratio 2 most likely to have. Probably oval. Elongated circle with round edges. Yeah, round. Circular. Snow. Which feature of the diamond dataset contains missing values? When restructuring technique, if any, should be applied to the diamond price. I'd say no restructuring, because why would you need to normalize or standardize diamond prices? Would remove the unit. So the maximum dimensions, width, length, and height of each diamond is measured in millimeters, which result if any should be applied to the diamond's width. Let's say normalization is because, like, what would you do with the z-score? No? Oh god, another trick question, bro. And the table describes the relationship between the size of the diamond's top edge and the rest of the diamond. The ideal diamond table is considered to be 60. None. No! The table is unitless but has specific ideal values or a desired center. Oh, what the heck? Not even normalize it. Standardize it? What? Standardizing on the mean would give 60. So, normalization table value shows 0 because that's a table above desired size. Depth. Average depth is calculated and used to replace those values, which words of limitation described. What do you mean? Each feature below has an outlier, which is the only feature without extreme outliers as far as data. Only length. So I'm going to get a length that big. So price the carrot then. Price. The history of a price is skewed, which Down's price is below $5. Oh, which statement has a low average price? Oh, it's the fair one, or the very good one. JD, haircut J. With the lowest. Oh, wait, that's the least dimes. Let's see. Look. Price. Okay. We finished with 4. I just need chapters 5. chapter 5 and then chapter 6. So we have 7 here and 9 here. But I don't think we have to do the lab, so it's just forget about. Oh, I already took that out. Okay, so alright, let's do it. How many people between the age of 50 and 59 were diagnosed with COVID-19 in the past 2 weeks? 15, 59, 2296. How many people under the age of 20? It's 1087. Like 5K. I ain't doing all that math. How many people between the age of 20 and 39? It's like 6,083. What is the issue with this plot? Changing the numbers of years in each category leads to pursuing fewer cases in children than in adults. I don't think they changed the year. They kept it pretty similar, huh? No labels on the axes. Yeah. And changing the number of years, including in each bar. What? What is changing the number of years included in each bar? So histogram is not good for this, huh? An analyst should always label the axis of a plot, and if ranges are different sizes, adjusting the bar accordingly, especially when communicating to the general public. Oh, so these are like 0 to 4. This is 9 years, huh? Yeah, it's usually all 9 years, but we have like. I don't really get it, but I'm trying to make the sense out of it. Alright, I studied long enough. Bye bye.